Hi, everyone. Welcome to today's talk about, I'm going to be talking about consuming packages and how we consume packages in C++ projects. My name is Luis. I am a software lead with the Conan team at JFrog. So we are very much exposed to the problem of how we consume packages. So hopefully you'll enjoy today's talk. I wanted to start talking about the 2022 Onion C++ Developer Survey. The results were published a few months ago. And one of the questions was, how do you manage your C++ first and third-party libraries? Now, for this talk, I'm going to be focusing more on the third-party library aspect, although some of the concepts can still apply. So what was surprising to me was that the top answer was, and let me show this better, that the library source code is part of my build. Now, these days, there are tools like Conan and vcpkg that sort of simplify these workflows, right? So what surprised me a lot is that like building external code from source with your project is still the most popular choice. Now, for me, this isn't necessarily like a bad thing. You could have like really good reasons to do this. If you use sanitizers regularly, for instance, it's actually really handy to have like full control of being able to generate instrumented code in order to run your tests with like sanitizers enabled. Because if you read documentation, they're likely to say that you should build all of your code and all of your dependencies with the same sanitizer instrumentation. So let me see here. Another question in the same survey was, which of these things do you find frustrating, right? And obviously, as that's the subject of the talk, managing my the libraries of my application depends on. But one thing I was looking at is like the second most frustrating thing that C++ developers find is build times. And I'm thinking, well, we are building all this external code as part of our project. So it's like no wonder why we're complaining about build times if consuming libraries actually increases the time we spend compiling code. But I was thinking, what does it actually mean when we say the library source code is part of my build? So we have our project, we have our source files, we have our build scripts. It could be CMake, it could be Meson, it could be Visual Studio Solution with Visual Studio projects. And what we're likely to have if we're actually building third-party libraries from source, is this folder, right? The third-party folder, we've all seen it, and all things can happen inside that folder. And just as an example with zlib, we're going to have the zlib source files, and it's a single library, has about 15 source files and 2 public header files, so it's not too much. But then we have the problem of how do we actually build it, right? So as I mentioned before, we have our own build scripts. It could be CMake or something else. But how do we build zlib, right? And we're likely, like, do we use the build scripts that come with the library? What if they're not in the same format or the same build system that we use ourselves, right? So what I've seen in a lot of open source projects is that people will write their own build scripts just for the zlib sources that they have in their project. So this is an example, for instance, in protobuf, there's like, I think they use Bazel, and they have just like the zlib build script for this that they have written, right? So it's about 69 lines. Another example, for instance, we get OpenCV with 105 lines. They write it in CMake. Next one is Qt5, which used to be based in CMake as well. This one is 20 lines. It's not too bad, right? zlib is like a smallish library compared to others. And I think, yeah, sorry. So this means, at least in this instance, when you're consuming a library like this, you have to be aware of which source files they have, and you have to like write yourself how to build it in your project, right? But what about a different library? What about Boost, right? It's no longer like, I don't know, 16 source files. You get a lot more source files to build. And if you follow the same approach where you have to roll your own build scripts for Boost, it's going to be like a massive file or set of files, really. So does this actually happen in open source projects? With zlib, for instance, I find copies, embedded copies of zlib in a lot of open source projects. With Boost, not so much, but I did find this. It's basically like basal rules to build Boost from source and standing at like over 2,500 lines of code. So as far as I'm concerned, like looking at this is a re-implementation of the Boost build script. So, and while in open source, you're less likely to find things like this because Boost is a really big set of libraries, sorry. I'm sure that in proprietary code and a lot of companies, developers are building at least portions of Boost, right? But there's other ways where we maybe don't need to embed or host the source files of Boost to consume it, right? What we could do, if your build system supports it, is we can instruct our build system to download the source files from an external place, like a tarball or something like that, and build it as one of the steps. So a lot of build systems are completely agnostic as to what you tell them to do, right? So you could invoke the compiler to build a library, or you could invoke wget to just fetch the sources and invoke the build system of that particular library. And I've also found another one for Bazel, I think, that does the same thing for Boost. So that's like a different way of doing it. And the last one I wanted to mention was sometimes you have your own build scripts, and the build scripts of the library you're consuming are in the same format. Oh, maybe they're also using CMake, or they provide a Visual Studio project that I can add to my solution, right? You may be able to do like what I'm calling project composition, right? You just like on CMake we have app subdirectory. That could work. My experience with it is like every project is going to act as if they are the top level project, and your ability for this to work, it doesn't always work. So what happens sometimes is like people realize, oh, hold on a second, if I don't have to like host the source files or write a build script, I'm going to turn it into a submodule, right? Sort of bright ideas that we've all had in the past that end up backfiring sometimes. So because of all this sort of like challenging scenario of consuming libraries, header-only libraries have become like really popular, for better or for worse. So it's a simplest case. It leaves like a really small footprint on your build scripts. Technically, all you have to do is expose and include directory to the rest of your code that reference it. And also, this shows like more than 1 in 4 recipes in Conan Center are header-only or have the option of being header-only. So you can see that like it does make me wonder sometimes, do these libraries have to be header-only for technical reasons? Or if it wasn't such a challenging way of consuming libraries, would they have taken a different approach, right? Library authors know that consuming libraries is difficult, so they do try to make their libraries header-only for others to use. So for instance, in Reddit, every now and then I see, oh, a header-only library. Here's mine with awesome features. So this happens like a lot. And it just makes me realize if you're an author that wants your new library to be used, you're going to go for header-only more likely than not, just because it's otherwise difficult to get traction and for people to use your library. I think an example is the format library, FMT. It does have a mode of being header-only just to help with this, but it also has the ability to just be a compiled library and consume it like that. It's got to the point that there's even a curated list of awesome header-only C++ libraries that I think is being kept up to date from when I checked. So it's definitely a thing, right? And to me, this is like, it's like giving up, right? You have, C++ libraries, but it's so difficult to consume them that just like, okay, you know what? I'm gonna do header-only for better or for worse. So as a recap of this, these are like, I've just sort of explained multiple ways of what people call vendoring your dependencies inside of your project. If you are like the end consumer of that project, or if you're developing that project yourself, this is actually convenient, right? You do pay a price in compile times, depending on how many libraries you're building, but it might just work, right? Whereas things get a little more difficult if you depend on a library that does this, right? In particular, if that library has dependencies on other libraries that you also happen to use. then what happens with the version mismatch? You depend on like version A and they depend on version B, and there may be like, I don't know, symbol collisions depending on how you structure your project. This is not easy. This is also a huge headache for package repository maintainers, where they have to do the opposite. They have to somehow force this library to consume libraries externally, right? So again, if you want your library to be used by others and you want it to be published in these repositories, you're probably going to have to maintain both ways of doing it. The one where you pull sources or build external sources, or one where it's provided externally, right? So that also causes some a maintenance burden for you. So we have sort of, these are like the different ones that I've shown. And we have obviously the third-party layer, right? In the first case, you have to know what source files this library has and how to build them. And some libraries is easy, like Zilib earlier, but for some libraries, you may have to like have special like compiler flags and special files, or like propagate certain compiler definition, stuff like that. In the second case, you have to know at least a URL to download the sources and how to invoke the build system for that library. And as we all aware, and this could be like a completely different talk, there is no standard way of invoking a build system, right? You're lucky if people follow the standard CMake, if their project is CMake. But CMake also has like spans like many years of like shifting practices as well, have been evolving. So there really isn't a way of doing that. So this is going to be like specific to each library. And in this way, where you're lucky enough that their build system is compatible with yours, on paper. On practice, it could be difficult. And also, I have seen projects that use submodules sort of recursively as well. So it's like some of the submodules for the dependencies depend on other things that you've already cloned before. And it's a very interesting experiment, to say the least. But it can actually work. Like if people do these things, it's because it works, no matter how difficult it is to maintain. But what about your build scripts? I think, and the focus of my talk is going to be, how do your build scripts reference this code that is not yours, right? That is not part of your project, is externally provided. So it's basically, what do we do? And this depends on what abstractions are provided to you by the build system that you're using, right? These days, like I think we've all sort of might have heard about modern CMake and how to use in like transitive usage requirements rather than other ways of doing it, which is like passing flags, right? A different workflow is somebody has to tell you which flags you have to pass to the compiler to be able to find header files, and which flags you have to pass to the linker as well for the linker to be able to find the symbols. But modern CMake these days, and I believe Bazel has a similar concept as well, is like all you need as a consumer is basically just the name of the CMake calls it a target for these things to be propagated to your sources, right? So here's an example. I have in a CMake file, I have a hello project, hello CPP, and I want to link against Boost file system, right? What happens under the hood is that CMake will take this information from this target, from the properties that it has a knowledge about, and it will propagate the, actually I should have highlighted all this as well, right? It will propagate the compiler flags that are needed to compile a file successfully, and it will also propagate the linker flags that are needed for the executable or the share library to link successfully, right? So, but as a developer from your side, all you need to know about is this, right? So when you compare before all the things you needed to know about the libraries, like their source files, how to build them, where to download them from, now all you need to know is just one thing, right? The target. So our code might interact with external libraries in this way using transitive requirements, and CMake calls them targets. But who performs this translation, right? As I mentioned before, this is something that is going to be part of sort of a feature of the build system. But I think what's important to ask ourselves is who provide this information and when and how, right? And I think that's going to be the big topic of this talk. Another alternative that I didn't mention earlier, but it's good mentioning now, is the find logic, right? And you're more likely to find it in CMake as well, but it's like maybe you have a binary compile library that lives somewhere in your file system, and you know something about that, right? It could be the file names. It could be that there's a common file system locations, or you already know yourself which other libraries it depends on, right? I know, for instance, like libpng, it depends on zlib. We know that, right? So that you could encode that in your build system. So that's kind of like the find logic in CMake, the find scripts. They encode this information, right? But for Boost, for zlib, again, 194 lines, which surprisingly is actually more lines than what it takes to actually build it with the sources. But for something like Boost, these days that file is 2,600 lines of code, right? Which is also bigger than the basal implementation of the Boost file system. So this is a lot of ground to cover. Now, okay, some of these files are actually that big because they're targeting all the different naming conventions of the particular libraries on all the platforms, right? Especially on Windows, depending on whether you're building like multi-threaded or not, the file name is going to be different, so that needs to be encoded. And this is a huge problem whenever Boost is updated. If you want to use a new version of Boost, you need to make sure that the assumptions that you made about Boost still hold true, right? So sometimes they do, sometimes they don't, right? And this shouldn't be the bit that we need to, in my opinion, even be aware of in our build system. So, like, I do like the find logic at least because it allows you, especially if it uses targets, like I mentioned earlier, to isolate the rest of your build scripts from the underlying logic on how that is populated, right? So there's actually a good use of the encapsulation principle, right? If your build scripts only refer to the external library as foo : lead foo, then at least to you as a developer, it doesn't matter how that information got there, right? As long as it gets there. Although if this file is part of your project, probably somebody in your team definitely does need to care. But what this allows us to do is what sort of is the preferred way of working with CMake, which is you can have a binary package of this library that contains the exported target information from CMake. So when this library was built, CMake is able to generate a file that contains information. So that means that you no longer have to have this find logic. And all you need to do is you only need to know the name of the package and the name of the target that you want to use. So config files packaged with binaries, right? Oh, this is what I just said. Name of the package and then component name. And the rest of the things that I mentioned earlier, they can now be actually private and completely decoupled from our build scripts. The file structure and the file names in the source files of the dependency, the build system that the dependency uses to be built with, or how to invoke it, or the file names of the compile libraries, all of these can now be hidden from a developer's view, right? So, and to me, this actually enables using all of the other mechanisms to consume libraries, right? With one sort of big caveat is like I just described the CMake way of doing it. It means that your project needs to also be using CMake, right? So, and I've seen some of this as well, you may be using a different build system and you decide to parse the CMake-config files yourself to get this information. That's possible, but you have to be mindful that CMake is also a scripting language, right? So it's not only like a declarative properties situation. It could actually have some logic as well that you may not be able to do. But there's still a few unanswered questions here. How does our build system know where to locate this file? And this is what I believe where package managers can be handy. And who and when is this file generated? And obviously, the big shortcoming is that this isn't build system agnostic. You have to be using CMake to consume these files, and it may contain more things than just being descriptive. For instance, I think Qt it defines some CMake functions that you have to invoke in order for automatically invoke the code generators for your Qt-based files to compile correctly. So there's more than just a description of the contents of the package, right? Now, this is an open issue, and it was created 2 years ago in the in the CMake issue tracker, right? There is definitely demand for a build system agnostic package export format, right? But it's still like even 2 years later, there's still no traction. These are like no practical solutions. But using CMake-config files that are generated and bundled with a binary package, this is far from a new concept. This is something that Pkg-Config and Libtool have been doing for years, for a really long time, especially like in the Linux world. So Libtool, there's metadata files that are going to be generated alongside the library files, right? And they will, in particular, they have exactly the same name as the libraries. And Pkg-Config, which you may be a lot more familiar with, it just has these PC files that are bundled somewhere in the compile package, right? So Libtool is an interesting thing because it parses the information implicitly, but you have to invoke the compiler via Libtool, right? So you're not going to see that in many projects other than projects that implement new build system conventions, right? So this is not something that you're likely to see otherwise in CMake or modern projects. This is something that's typically done for you if you use auto tools. And what it does is it will parse this file and then populate the flags before invoking the compiler for you or the linker, right? Whereas Pkg-Config, and here's an example of like 2 PC files for two different libraries, you have to invoke Pkg-Config yourself to query it. Hey, you give it a package name, and you're like, please give me the compiler flags that I need to pass to the compiler, and it will give you that, and you can just pass those flags directly to the compiler. So it's very sort of flags oriented, and also the equivalent for the linker as well. So this is different from the CMake like the modern imported targets, in that you still have to, somewhere in your build system, you have to say, hey, compiler, please use these flags. Hey, linker, please use these other flags. So that's 2 steps instead of 1, like I showed earlier. But this remains like a very popular way of doing it, in spite of the shortcomings. Oops, I think I'm missing. Sorry about that. I'm going to show all of this now. So Libtool and Pkg-Config today. Libtool, you have to explicitly invoke the Libtool to do the compiling and linking for you. It's limited, like I said, to a very specific subset of projects. And from what I understand, even Linux system maintainers are actually advising people to remove those files from the packages if they're there, because for the most part, Pkg-Config will cover most of the use cases these days, right? So it's been an interesting story with that. But Pkg-Config is very popular, especially in like Unix-like environments. It does have some limitations, like something I read about a lot is like it can only describe a single component. And a lot of libraries, or collections of libraries like Boost or Qt, they have like complex relationships between their own components, right? But it's also oriented to flags, and which kind of like limits the. Although I know GCC and Clang and Linux in particular, they try to keep the same command line interface, right? It just sort of makes an assumption that you're using a compiler that is compatible with the same flags, right? And like I mentioned before, it's still very flags oriented, which I'm always a bit worried about whether or not that's the right thing to do. So where we are today for for projects that can actually create a binary package, they're likely to have either a CMake-config file or a Pkg-Config file, or both. So that's sort of where we are today in terms of being able to consume these libraries. And as a recap, we want our build script to not be concerned about all these other things that I mentioned earlier, like how to the external sources and how they're built. And we also probably want to be agnostic to how and where the library was built. It was like these days, like Conan vcpkg can give you a pre-compiled, pre-built package expose it to your project, and that's all you have to worry about. And like I mentioned, the current approaches have limitations, in particular around how the interoperability between those files that are generated and the build systems that your own project is using. So I think part of the problem in this instance is the concept of what is a library has been evolving over time, but also it probably has a different meaning depending on who is, dealing with this library. So I think the first thing that maybe comes to mind is, okay, a library is a library file, is where the compile symbols are, right? So, but the library is also used by the dynamic linker when you're running your executable and it needs to allocate the symbols at runtime, right? It's also used by the static linker when you're creating the executable as well. Maybe you are, have static libraries in your project, and maybe those static libraries depend on other libraries as well that you're also going to have to link, right? So now at link time, the static linker, you're going to have to be concerned about what these dependencies are in order for your application or library to actually be linked successfully, right? The compiler, on the other hand, you may say, oh, well, this is part of a library, but you need to, the compiler needs to be able to see this file to be able to, process the includes. And maybe you need to pass a flag telling the compiler, hey, this is the directory where you're going to find those files. Now, in the near future, we may need to add more files that expose the module interface units, right? And also additional information on what the compiler needs to do on the consumer end to be able to compile the module interface unit, right? So this is still in flux, and there's a lot of papers discussing this as well. Is modules add a new layer of complexity on top of what we already have. Now, to the build system, a library could be the config file that is created and bundled with the rest of the artifacts. But to the developer, maybe the developer only cares about the components that they have to use, right? So, and I think this is my experience as well. This is the only thing I want to expose the developers in my team when it comes to external libraries is just a target name, right? I don't want it to have to deal with linking order or whether or not they have to worry about the modules in the future, right? Or passing flags and having to be aware of that. So, all of these files, you could say they are a package. So maybe we have two concepts now. We have the concept of a library, but we also have the concept of a package. And where there's a package, there's probably a package manager that also has something to say about that, right? So what is the way forward, right? And for me, it's focus on the developer. The developers are the ones that are calling functions that are provided by other libraries. So make it easier for them. If this is something that we want our developers to be doing, let's make that happen, right? And this almost inevitably starts with build system support. If your build system doesn't support transitive usage requirements, there's a chance that your developers are still going to have to be exposed to fiddling with compiler link flags, right? We want, and also the build system, if there is a file that actually has this information for the build system to actually translate internally to these flags, the build system needs to be able to parse this information from a potential package description file, like CMake does for the ones that it has. But we also want interoperability. We don't want a library that only provides the CMake files, which means that the only consumers that can actually successfully consume that are using CMake, right? So it would be great if different build systems, if a standard package description file existed and different build systems could implement support for this such that they could translate this to the flags that are required to resolve a statement like that, right? So that we finally achieve decoupling our build system from the libraries that we are consuming. And I think this is basically one of the major pain points, even if you use package managers like Conan and vcpkg. So in the past several years, there have been multiple proposed approaches to sort of address the situation, especially a more agnostic file that is not CMake only. So for instance, we have the common package specification that was proposed sometime in 2018, and it's a JSON file, right? And to me, and this file is presumably generated when we're building or packaging the library. It has interesting things, like it has a concept of an interface library, right? It's a library that doesn't actually have an underlying library file, like a shared library or an archive, to be passed to the linker. Maybe it's just an actually header-only library. So there's like, at least, if you look at the different proposals, there is some commonalities in the functionalities they provide, right? Interface library is a good one. This one as well, and I do find it interesting, for the packages generated, is sort of noting, oh, this is Intel x86-64, and we are on Linux. And I also have these different configurations like optimized code, or people may call it release, or debug as well, right? So I kind of feel like that's some notion of binary compatibility as well. And myself, I'm not entirely sure like the package description format, at least in terms of how to consume the library, needs to be concerned with this. But on the other hand, being able to detect incompatibilities early on might actually help a lot with showing meaningful errors to users, right? Imagine if this information wasn't there for whatever reason, and then you accidentally pull the Linux packages on Windows, right? What's the Windows linker going to do when you're trying to link against an ELF binary? So I suppose those are the type of things that we also need to think about in terms of like the usability. When there's an error, what happens, right? But an open question for me is like, should this package description format concern itself with binary compatibility, or at least, or is this something that could perhaps be part of the responsibilities of the C++ package manager if we're using such a thing? Another proposal that we have, and I did really like this one as well, is Litman, right? This was proposed sometime in 2019, and it does have basically, like I've just mentioned, like two concepts, like very distinct concepts: packages and libraries. A package is a collection of libraries, and I think here they have the LML extension, right? And you just basically specify, like I was saying earlier, just focuses on the name and the namespace for the targets that you will link against. It expresses its requirements, and it just say, okay, this is the collection of libraries that are in this package. And then the library files themselves, so this would be an example of an LML file. You just have, well, the name of the library, the dependencies, I suppose, of that library as well at a library level, and the path of the actual file that we would eventually have to sort of tell a linker about, right? So this is a far more like simplified way of doing it. Perhaps it's like more minimalistic, and I think it's a very interesting approach here. And if I go back, sorry about this. This is described already in the title as a bridge between the dependency manager and the build system, right? And I'll get to that in a minute. So this is something that they say as a goal: define the requirements for the dependency and package manager to generate the correct set of files that our project is going to consume. So now we're involving the package manager more. And a non-goal is we're not concerned with defining the semantics of version compatibility between libraries, right? And I wonder if that's also related to the stuff about whether I'm saying that, oh, this is x86 on Linux or Mac OS or Windows, or even sometimes seemingly arbitrary incompatibilities that you could have between your libraries. So I suppose, based on this proposal, it makes me wonder, why is the role of the package manager, and how can the package manager help in this situation, and should it be involved at all? So the way that we have it at the moment, at least for those projects that do package either a Pkg-Config file or a CMake configuration file, is that they just package contents that already exist, right? This file was generated alongside all this other when the package was created. And you may have a package manager in the middle, but the contents of this file are exposed to the consumer just as they are, right? And let me try to show all these slides. Sorry about that. So these days, we do have modern dedicated C++ package managers, like I mentioned, Conan and vcpkg, and they do have support for some of those things that were, like I mentioned earlier, like maybe they actually do have support for building libraries from source if you want to. There's an ability to model ABI compatibility between libraries, or to model whether something is a Linux binary or macOS binaries, and provide integrations with build systems as well. But I suppose the big thing for me is like it has the ability to resolve the dependency graphs given a list of dependencies, and concepts like the visibility and the transitive requirements and different variants of the same package. But there's one fundamental aspect, and sorry for the animations that were out of sync, that the package manager knows one thing that complements the package description files, which is where they are, right? And when you think about the information that eventually makes its way all the way to the compiler and the linker, it's actually file paths, right? And this is important to note for me, because we're going to have a potential package description file. We may involve the package dependency manager in the middle to expose a set of files to the consumer. But the question is like why and what exactly is the package manager involved in? And one good reason for this is that this descriptor is likely to reference dependencies, right? So I have my library and I'm saying, oh, hey, in order to link against my library, you have to link against another library that is not part of my package. How is that dealt with at the moment? I'll get to that in one of the next few slides. Is that at least if we involve the package dependency manager, the package manager has the ability to resolve that dependency. So at least it can tell us the where, and I think that's important. One of the sort of risks that we have these days with how this is done sometimes is that from some of the, at least the ones I've seen, generated Pkg-Config files or Libtool files, or even some of the exported CMake files, they often contain hard-coded absolute paths that made sense on the machine where the project was actually built, right? But may not make sense in the machine where the project was actually consumed. So that here's where we actually usually have issues, is that is it the job of the package description file that has all these transitive usage requirements to tell you where to find other libraries? Because that is what I've seen in some of these files. And if not, they rely on one implicit and underlying assumption that you just install it on one of the standard paths in your file system, right? And that approach may actually be okay when you're installing in user local, for instance, on Linux or Mac OS. And it may also be okay if your workflows impose that every library is built from source at least once on the machine where you're doing the build, right? Because in that case, if you have hard-coded absolute paths and they're guaranteed to exist on that machine, then it's fine. But when you have sort of package managers that may put in different places or a different workflow, that's not always guaranteed. And I just want to talk about as well, because this is what brings me here, is how we achieve interoperability with different build systems in Conan, right? So we have our C++ project, our code, our arbitrary build system, and we have a file that, this is sort of a simple one that expresses the dependencies, right? And maybe I depend on zlib and boost and the format library, and I just put that information in a Conan file .txt. So I run Conan install, it will parse this file, it will resolve the dependency graph, and then depending on the generator that I tell Conan to use, it can actually generate Pkg-Config files, CMake-Config files, Visual Studio property files, Xcode config files, and environment variables that are understood by AutoTools build systems, right? So in a way, we do try to provide, hey, it doesn't matter what build system you're using to be able to consume these libraries. And this is something that we maintain very much in Conan Center as well, in all of the packages that we make publicly available, right? So this functionality in Conan requires the recipes to express the information that would otherwise be contained in a package description files, right? So the transitive usage requirements, the compiler flags, they include directories, the dependencies between the components. So this, to me, sounds like we're duplicating information that could/should be provided by the actual package, right? But because there's no standard way of consuming that information, we might be in a place where we have to parse CMake-config files, which we really want to avoid. And also, this for complex like packages like Boost or Qt, this can be a lot of lines of information, right? And you basically back to square one is, in order to consume this library, I have to know all of these things and I have to encode that, right? Obviously, because Conan recipes encode how to build a library, sure, there's some things that you cannot escape. But at the same time, it allows us to hide this complexity from the consumers. So in terms of, to achieve at least a sense of interoperability. So a remarkable amount of heavy lifting is done by repository maintainers. So we have Conan Center, we have VC package ports, we have homebrew formulas, right? And all these other like public package repositories. If you've ever sort of inspected the content of those repositories, in order for them to successfully build and curate all these libraries, there's a lot of patching going on, right? Like a lot, and depending on like the different individual aspects of all these repositories, they're going to be different. But the underlying thing there is that the patches are, in a lot of times at least, done to successfully when a dependency consumes libraries from a different package, right? So that dependency is used already provided externally to the repository. So, and this kind of creates this island of things that work, but they're different, right? So this links to lock-in. If you've been using, Ubuntu Debian packages for years, you're less likely to want to, or less likely to have it easy to test a different solution. What about if you want to use Conan tomorrow and VC package the day after tomorrow, just to test sort of different workflows that they might satisfy and your team members may find useful, right? So that makes it harder. So we live in a world where like some things are actually easy, but only if you use certain tools in a specific way. There's no interoperability. There's no easy way of switching things. And that is what I think that we could start solving by having a format of a compiled binary package that has this information. So, sort of as closing remarks, summarize the presentation. To this day, there's no standard way of libraries to communicate the usage requirement to consumers. There are some ways, like the CMake export to targets. Otherwise, and as I've tried to show today, developers will fall back to like a myriad of different ways of consuming dependencies. And it's also very likely that you're going to find projects that consume libraries in more than one way in the same project, right? I've seen projects that, there's a third-party folder, and for one particular reason, at least one dependency had to be built from source alongside everything else, right? And the same project may be consuming a system dependency from an Ubuntu package, and also maybe from Conan or VC package, right? So we are sort of doing this to ourselves because there is no easier way of doing this. If you, on the other hand, at least in your project, you choose to use a publicly available repository, right? The repository maintainers are doing all the heavy lifting for you in different ways because they have patches for everything, right? So that you don't have to worry about it. But you may be working in a company where you want to your developers to consume binary packages from other teams in your organization, right? So it's not necessarily easy to sort of, okay, now I have to design my packages in a very specific way, or to match this already existing ecosystem. The concept of a library has evolved over the years, and there's multiple different levels at which we are concerned about a library. We have the compiler, the linker, the runtime linker, the build system, the developer, and now with modules as well. Are modules part of a library? Are like the binary artifacts of modules? Is that something that we're interested in bundling with a library, or do we have to, which I think is going to be likely to be the case, expose a file to build our compiler needs to compile, right? So that imports can be resolved, and also maybe a mapping between the names of the modules and the files that the compiler needs to build, such that the build system can work out how to order the build in the first place, right? So we have all these levels that are actually completely decoupled. The runtime linker doesn't have to know that a library was built from C++. It could be C, it could be Fortran, it could be Rust. So it's like, because I've seen some examples as well. Would a single file format for a library work for all these use cases? I don't think so. I don't think we can impose more things on the runtime linker, for instance. And in fact, some of the newer linkers on Linux, at least, they want to decouple themselves from anything that happens at runtime when it comes to dependency resolution. Like I mentioned earlier, C++ modules are definitely going to add a new level of complexity, and I think we need to start thinking about how we're going to. I mean, I know there's already a lot of work going on this topic at the moment, but we need to get it right? Otherwise, we're just adding a different way of doing things that has its own drawbacks, and maybe adding +1 things of doing the same thing. I don't think that's going to keep developers happy. There have been proposals to fix this, but they have not gained much traction in the past few years, and it makes you wonder why, right? Some of these proposals are actually quite sound, right? And I suppose, at least I would guess, that it's because the scope is huge, whereas the language as a standard, right? It's focused on the language, and now we're talking about the whole tooling ecosystem as a whole, right? And that's probably way outside of the scope of what we can make standard, but that doesn't mean that we cannot do something about it. So I think all we need to do is fix it. Let's get together. I work with the Conan team as well, and I know there's sort of other maintainers of other tools that are interested in finding a solution to this sort of problem. So I think, much like some of the best functionality that has made its way into the C++ standard library started outside of the C++ standard library, maybe we need something that already works outside of any standard and prove that it works and get traction and find a compatibility between the existing tools in the ecosystem. So that sort of concludes my my presentation. So thank you very much for attending, and any questions? Questions? Sorry. Is this something that kind of rings a bell? Is this things that you have seen in your projects that you would like to see a better way of doing it? Nice. Or, well, not nice really. Some of these things are not pleasant.
Sorry. So on your slide, you said the CMake solution works well, and CMake's pretty ubiquitous. So if CMake were to start writing out some other format, do you think that would be adopted by package managers and other build systems?
Absolutely, yeah. So I think probably part of the solution goes through actually CMake doing this in a being able to expose this information in a different format that is perhaps more declarative and less like programmatic. And yeah, I think that that's the case. Yeah.
So I'm not super familiar with the Litman file format. That's interesting. I'll try to look up at that later. Off the top of your head, do you know, is it the right design to be extensible to the new requirements for modules to be able to parse the interfaces, or is that going to be too complicated for it?
I haven't looked too much into that, but I don't think so. Like, it's basically, at least the complexity that I got to see is what I just showed.
Yeah,
right?
they look pretty simple, like how we're going to shove a bunch of compile definitions in there and that sort of thing. Maybe it's possible. I was just wondering if you know off the top of your head.
I'm sure it is. Yeah, it would be good, because I actually like sort of the simplicity of it and the fact that it was like, oh, let's not think of API compatibility and all that. It's just is the information. What I don't know is, like I mentioned as well with Qt, right? It's like some projects have executables that they expose for you to use at your own build time, right? Like the protobuf compiler or the MOC compiler, the meta-object compiler in Qt. So it would be, I don't know if this is in the scope of like the package descriptor should contain, but it's also, again, more complexity that I know CMake handles, but how do we do it in a potential new format?
Yep, fair enough.
Modules brings up an sort of an interesting new problem in the fact that like you have to package source code sometimes.
Yeah, I think so.
And so it's starting to resemble a source package. Should we attack this from the source package side?
That's an interesting question. So you could argue in a way, right, that it could be thought of as a transitive user requirement. Is like, okay, now you have to build this file, but only if you have a dependency on the particular module that you're exporting, right? So I think what I've been seeing in some of the papers is exactly that. Is like mapping the module name with the file that needs to be invoked, and also somebody somewhere needs to get the right order of the compilation, right? And ideally, it would be the build system that's already doing that, right? Although I've seen other proposals that actually, propose that maybe the compiler, if it has enough information, it could trigger this cascade of compilations, right? At least I saw that like suggested in one of the papers, and I thought that was a very interesting approach. And now, like I said, now it's increasing the scope of what we're doing. Should the compiler be concerned now with compile order of things that is given? I don't know. Maybe, probably not, maybe not, maybe yes. We need to try it. Sorry, yeah.
Question from Dennis Bahadur. Why did the standard proposals not progress further? Is it maybe due to the out-of-scope C++ standard argument?
I would say that there's like 3 reasons for this. One of them is definitely the scope. I think the scope is much bigger than sort of what we've seen in the past. Also, there's a lot of activity on modules, right? And I think it's important that we get modules right. So maybe it just hasn't happened because there's a lot of people talking about modules. And the other one that perhaps is interesting, like I've seen implementations of being able to read these files from a build system, right? But I have not seen implementations of a build system creating these files for a package. So if a lot of people are using CMake, it's like, can we modify CMake to do that for us, right? So maybe it's something that we don't need to sort of like modify CMake itself. Maybe it's something that we can handle from a CMake script if we have like some sort of CMake module or CMake code that we can import. But I think in order to see a solution, we're going to need to see at least one build system exporting this file format in a way that is not something that's done after the fact with a different script or something like that.
So the point you made about supporting multiple languages in the face of all this is a good one. In my experience, it's extremely common for C++ to interoperate with other languages, including higher level languages that you didn't bring up, like Python packages and things like that.
Yeah, exactly.
Yeah. Right. Should we be arguing or scoping for a larger systems language compiled to the native architecture package management spec, or should we be very specific and say we're just going to target, I guess, C and C++ since it's hard to distinguish? Or what do you think about that?
Probably C++ and well, C and C++. Yeah, I don't like the complexity of all the others. This is what I think, for instance, a potential magical solution could be a single file format, right? We have, for instance, on macOS as a framework files, which have the library that is needed at runtime, at link time, but also has the headers, right? So, okay, it's an actually folder structure that sort of pretends to be a file. And another interesting thing that I saw from Clang, I think, is that there's some module metadata where you can specify link flags that kind of works like that Pragma in Visual Studio and Visual C++. So that's interesting. We're already starting to mix up, like, okay, can we actually have maybe one thing that works for all these parties? I'm not sure. I have like my doubts about whether or not we could actually sort of come up with a thing that works for everything and for all these things.
I guess I asked my question because a lot of people want to try new and different systems languages out.
Yeah.
And if the expectation is that those languages link against C++, don't we need a common way to say how that would actually work? Like how would you build against those interfaces? How would you link against
if they are consuming the C++ part, maybe that's it. I suppose the complexity comes with...
So if C++ is at the bottom, it's not a problem.
Yeah,
because we have a standard format. But if C++ is at the... it gets complicated if you have to start interleaving languages or something. Right?
Yeah, for sure. Yeah, I think so. Yeah.
Right.
Do you have an idea for how people should start collaborating on this?
This is something that we were talking this morning here at CppCon. Is basically, I think if you actually look at what's been proposed already, like there's a lot of progress, right? It's just like we need to implement this or approve a concept or something like that, and just like start from there. So, we're going to be around. I'm from the Conan team as well. Let's do it. Like let's talk about it and let's get some coordination and do it. Awesome. Any more questions?
Oh.
Yeah.
There's one question from FCHA-bot. Do you think that the big number of proposed solutions that didn't get tractions is the proof that this is something that has to be addressed from a CPP standard standpoint? I feel a lot of devs will be turned off providing support to multiple package managers / build systems.
That is a very good question. So at least I've always heard that like the scope of the standard doesn't go beyond the language itself, right? So this involves a lot more than that. So, but at the same time, there is a working group for this, right? So there's probably like some sort of blessing of like working together, perhaps as a process of how we get there. We could do it as a standard. I'm not entirely sure, especially because of how many tools it impacts, right? So, but like I said earlier, I think probably the main reason that they haven't got traction has to do with we need build systems that actually support this. And it's not just supporting the package like specifier. Is some build systems don't have the concept of transitive usage requirements yet, right? Some build systems require you to actually specify the flags in particular places. So that's also going to be another problem, yeah.